All right, our next speaker is going to be talking about dredging, and if we can all give him our attention. I think we all got very involved in the last speak. This speaker says he's going to be a lot more, it's going to be friendly fire on this topic. So. Here we go, J.Ragan.
Thank you, Alan. Good morning, everybody. And again, my name is J.Ragan, and thank you for the opportunity for me to talk with you today. Dredging is a very large topic, so I've tried to put together a presentation today that will at least give you a good overview of dredging. And I'm sure, based on what I observed with David's presentation, you'll have some spirited comments for me. So please feel free to jump in as I go along. I'm going to move around to different topics. So if something you see really interests you, feel free to let me know. But so to start. I put together the agenda to talk about what is dredging and why is it necessary. And just again, big overview topic. I'll go through the two main approaches, and then I'll talk about planning, assessing why dredging is necessary. That's very important for lake associations as well as boards, because the membership is going to want to know why dredging is necessary. In many instances, you kind of already know, right? By the time it gets to the point of needing to dredge, it's too late. So planning is really critical. So I'll go through some of the various steps of doing a water quality planning and management assessment study, sediment characterization and management, a big topic. It covers a lot of areas, and then this is a topic that I see a lot of value in, and I think it's important to a lot of associations. This is a topic unto itself, and should really be thought of before you get to dredging, because it's things that you can do preemptively to try to minimize sediment and organic matter coming into lakes, so that you don't end up having to manage it afterwards. Permitting requirements, regulatorily, there's a lot of hurdles, adds a lot of expense to projects, and so it's something that is very important and can really help in the planning process, because permitting, dredging, it's a 5-year permit that we can achieve from the DEP, and then it could be extended for another 5 years. So again, as part of your planning, it's important, because financially and how you execute a dredging project can go on for many years. And I talk to a lot of my clients about how the value of planning for the financial aspects of it over that 10-year period is critical, and it just affects a lot of the operations of the facilities. I'll give some closing remarks and thoughts, and then we can have any detailed conversation that we would like. So that's kind of what I'm going to run you through today, and we'll see at the end how I can help you further. So what is dredging? Dredging basically is the removal of organic matter and accumulated lake bottom sediments. That happens from a lot of natural processes, can also be accelerated by man-made activities. I have a lot of associations where they watershed directly adjacent to the lake was heavily wooded and naturally vegetated a long time ago, and then as years have gone on, members, property owners have cut the trees. They prefer to have grass over natural vegetation, and that has accelerated the deposition of organic matter, as well as adding nutrients and other things, which we won't get into today. But that affects the water quality of the lake. A lot of our lakes are now dealing with the algal blooms and other things that are a function of the nutrients. The dredging process essentially consists of 4 phases. You've got to loosen the bottom material. Every lake is different with respect to what the bottom material is. Again, for dredging purposes, we're really talking about the materials that have accumulated over time. So it's not deepening what the natural depth of the lake was. That's a whole different process and different permitting process through the DEP. So the way I'll be talking about dredging today is more focused on what has accumulated over time at the lake bottom and how to manage that. Then it's bringing the material vertically to the surface, so you've got to get it up right from the bottom of the lake to the surface, and then you've got to horizontally transport it from where you remove it over to where you're going to handle it. And then ultimately, you've got to place it somewhere. It's going to be very wet. It'll have to be dewatered. You'll have to store it somewhere. I mean, it can be managed wet. It just becomes more challenging, potentially more costly. So these are all considerations that will have to be made as part of your project. So this is just a graphic of vertically removing the sediment, and then this is grabbing it and then putting it on a barge and then bringing it over to the shoreline. Why dredge? So predominantly what I see from the associations I work with and lake owners is to restore the recreational access for boating, swimming, and fishing. I mean, those are the primary benefits of dredging. As well as obviously aesthetics are a big part of it as well. Improve water quality and health of the lake. This is not dredging. Dredging is not a sole factor that will help to improve the water quality and health, but it's certainly one of the many steps that can be a benefit. Other benefits are, sediment continues to move. If you look at this picture, the bottom portion here is, you can see a lot of sediment accumulation from inflowing streams of that nature. As storms occur and high flows come in, that sediment continues to get resuspended and migrated down into the impoundment, the water body. So that the benefit of removing that, it lessens that from making the conditions worse downstream. Improves fish habitat, reduces rooted aquatic plants, which many lakes deal with those challenges. And then there are lake-specific concerns. So, it can be the algal blooms, it could be limbia, it could be, shoreline issues. Again, a lot of them are site-specific to lakes. So I'll talk today, there's 2 basic dredging approaches. There's the hydraulic method of dredging and the mechanical method of dredging. Hydraulic dredging, both methods really require a lot of thought and planning as to what may be the best method for your lake. The dredging machinery for hydraulic dredging is essentially equipment that's floating on the hull of the watercraft, and then that moves around the water body to allow for augers and cutters to loosen that material so that it can then be suctioned from a pump system, and then that pump system through piping will then take it to some type of treatment facility. So this is a larger project on the bottom slide where it's a complicated dewatering process where the slurry material is being pumped from the barge system to a processing system where the water is removed from it, organic and sediment materials separated out, and then you'll see stockpiles over on the left side of the image. So a fairly complicated process, and I am not trying to make it look like hydraulic dredging is overly complicated, but it's more of needing the area to have these type of facilities in order to manage that type of process. And then there are conditions that are better managed by the different types of dredging approaches. So this particular process of hydraulic dredging works best in loose watery materials that obviously can be loosened, suction, conveyed by a piping system. If you've got cobbles, gravel, things that are hard to remove, which we do have in some of our lakes in this region, it's really not going to be a suitable method for dredging. I see a lot of mechanical dredging. Mechanical dredging can be approached as either wet or dry. So a lot of this, from a wet standpoint, has to do with the drafting, being able to draft the watercraft in order to move around the lake. If the lake has filled in so substantially that it can't be drafted, that could be a challenge, or that may have to be part of the process of creating a channel in order for the watercraft to move around. Dry dredging is accomplished by lowering the water level, or burring up areas to create areas where they can be dewatered, and then the material can actually be physically moved within the lake itself. And that would be accomplished with equipment that actually goes into the lake. Usually there's whole roads or access ways created. Other challenges again become you've got to get sometimes easements from property owners to allow the equipment to come through the properties and things of that nature. So again, just there's a lot to plan for and think about. Talked about the wet dredging, essentially being done without the drawdown. Excavators, drag lines, or grab buckets are what would be used for the mechanical dredging, and again, case-by-case basis. And then works best in hard-packed and/or rocky material than hydraulic dredging, as I mentioned earlier. So that gives you just a quick overview of the two dredging methods. Now I'm going to talk about water quality planning and management assessment studies. This to me is very important. It helps to give the board or ownership an understanding of what the challenges are, and how you can set forth a roadmap for going forward. And then it also helps in informing the membership of associations about the process that the board is going through, and how the process takes such a long time, because we see many times that folks that are owning or members of the associations don't really, they want to see something happen, right? The conditions are bad, how do we make it better, and would like to see something happen quickly. But being able to present studies with factual scientific basis really helps to educate everyone as to how the process can be navigated. So the water quality assessment basically will assess the status of the water quality, sediment impacts, and the overall health of the lake. What I would normally start with is review of what has been done in the past. Many times there's valuable information that already exists, and that helps to use that as a starting basis. Sediment accumulation and characterization analyses. The accumulation is basically where you're going to focus a lot of your efforts at, right? So you're going to have other areas that have more significant sediment accumulation than others, and because it's such a costly process, you may have to prioritize and or phase your dredging based on where you would essentially get the best bang for your buck. And then the characterization analysis is a significant topic because you've got to understand what you're managing, and then potentially what's within that sediment, what is characterized of, not only the physical characteristics but the chemical characteristics. And then stormwater feature upgrades and restoration, again, so you're going to identify as part of this study critical components of things as to water quality, but these preemptive measures from stormwater feature upgrades can be a benefit that you can implement in a faster time frame than you would be able to execute your dredging work. And then this also helps you to formulate recommendations and action items for next steps. And then you can coordinate with key stakeholders and develop a plan of action. Key stakeholders are obviously ownership, right? And then members, boards. But I find it critically important to engage other outside agencies. It may be the municipality that you're in. It may be also engaging the DEP in early conversations and finding the best path for your particular situation. It really is critical for you to strongly advocate for yourselves because it's a difficult process. It's not straightforward. The rules are the rules. However, the rules are applied differently with respect to certain circumstances. So all that is critical for engaging those stakeholders in those development of those critical action plans. So I'll talk about the lake's sediment impact assessment. What would be done is a watercraft would be placed on the lake and sediment cores taking of the bottom sediment to essentially see what it's composed of and also to help establish the bottom of the lake. You'll see a definitive change in the material from what has accumulated in the lake versus what the lake bottom was, depending on the origin of the lake. Many of the lakes that we deal with have been dammed up, so they were previously streams. So you'll find a stream bed channel configuration on the bottom, which is another important topic that comes up when I talk with lake owners many times too, is that especially for the adjoining property owners to the water body, they expect sometimes that as part of a dredging program that they're going to have a significant depth of water next to their properties after a dredging project is accomplished. However, what folks don't realize is that when the streams were dammed up, they sort of look like a V shape, right? Because the stream is a narrow channel, and then there was maybe some floodplain wetlands and things like that. So when the stream got dammed up, the water level rose, but along where the new shoreline is, that was a flat, usually a flat land, right? A wetland, something like that. So there was never really a lot of depth there to begin with. So that's something that sometimes comes as a surprise or a shock to membership, that they're expecting that they're going to have 3 or 4 feet of water along their shoreline, when at the end it may only be a few inches at best or something along those lines. So part of going through this process, you know, there'll be mapping of that, and then that allows the opportunity for that conversation. Initial characterization of chemical and physical material properties, a really important aspect of it. I'm asked many times, hey, can we resell our dredge material? And you know, it happens sometimes, not very often. So I wouldn't want anybody to get the impression that you have a saleable product. There were some lakes in Morris County that had a very sandy, gravelly bottom. Years ago, they were able to use that as construction base material, but generally, like in this core sample here, it's usually a very mucky, silty, or highly organic material, which has no engineering structural value. So, you know, at best, it can be used as recycled material that can be an organic. It gets blended into like a topsoil or something, but there's no real structural value to that type of material that we typically see. Identify potential dewatering material placement sites. You know, again, it just is another critical step in understanding what the sediment consists of, so then you can start to plan on how you're going to manage it. And that management comes from placement sites, also right through to where potentially you may dispose of it. Here's a graphic of a project at Shangman Lake where the sediment depths are mapped. So the darker yellow-brown colors are the deeper sediment accumulations. In this, at one of my earlier slides where I was talking about the sediment deposition upstream, that was actually Shangman Lake also. And that picture was showing this area here where there's two main tributaries that come into Shangman Lake. So you can see the sediment deposition is most significant there, and then it is distributed around. There's another inflow point here, which is bringing this sediment area in, and some of these other areas are just getting moved downstream as storms continue to move in the prevailing current pattern. So this becomes valuable for assessing critical areas needing sediment removal, and then also how you present it to the community with respect to why certain areas are being targeted over others for the greatest benefit. So temporary dewatering basins, another critical aspect of dredging projects. This is a project where a land-based dewatering system was set up. So there was a large berm area that was established, and you can just barely see a large excavator arm would swing over the trees and deposit the lake bottom material to dewater. And then where the water is collecting, there's an outlet structure that drains it back to a sediment filter before it gets to return to the lake. You can see it requires a large.
What's typical dewatering time?
Depends on what time of year. That's a factor, but it depends on the composition. But it could be several months to. I have other clients that leave it there for years, depending upon where they're managing it. So. There are some associations or property owners that look to manage it on site long term, which is valuable because then some of the sediment characterization and analyses that have to happen are minimized. When I say that is that if you're going to dispose of sediment off site, the state has rules and regulations for the chemical composition of it, how you dispose of it, and that greatly affects the cost of the disposal of it. So if you can manage it on site, that's great. That takes away that aspect of it. However, it's also a regulatory challenge because the DEP is going to be wanting us to make sure that we're not encroaching on a wetlands area, we're not encroaching on a floodplain, we're not creating any sediment discharge impacts that would affect downstream properties. So There are other factors that need to be evaluated with it, but it's a good way of managing material if you have that available to you. This particular site, when this is all done and the material is dewatered, in this case, sufficient enough to be loaded onto roll-off trucks and taken off site, that's how this site was going to be managed. So something like this could be managed because of the time of year within several weeks. And then this area would be restored back to what it was before, which was a natural grassed opened area. Another method is what are called geotubes, which is the trademark name. Essentially, this would work with hydraulic dredging, where the material slurry would be pumped into these fabric cylinders, essentially, that would allow the material to be dewatered, but managed in an organized fashion. This was actually a large dredging project, so you can define the area, you can manage it, and then those dewatering tubes would sit for an extended period of time. And essentially, when it's done, you end up having this like a cape or like a press type material, just due to the stacking and the arrangement and the weight of the material. So I'm going to jump now to best management practices. Again, to me, this is an important topic that I'd like to talk about because, again, dredging is complicated, right? So it's not something that can really be effectuated quickly, and best management practices, there are some things that can be done with, still require some effort, and also talking potentially with municipalities and others, depending upon the road systems and things like that, but can be a benefit. So I'll talk about inlet filters, rain gardens, and stream bank stabilization. So inlet filters, I've been a big advocate for inlet filters for a long time. They're a way of retrofitting existing catch basins around lakes and waterways that can collect organic leaf litter, sediment that runs off from the adjacent roadways and properties. And you know, this is a picture before the material is taken away, but you can see what was collected in the filter, and the benefit is you're collecting it here before it gets into your water body. So you know, as I was just saying, it helps to collect the material, and then to me, it's a preemptive measure that really works well. Again, it's not going to be, it's something that is going to require ongoing maintenance and things of that nature. Depending upon the number of catch basins you have, cumulatively it could provide a fairly significant benefit, but it also requires maintenance, and if you have municipal roadways, it requires cooperation by the municipality, and in many instances I've seen where towns will help with the management of these systems. Rain gardens, another way of managing stormwater. The volume of water can be infiltrated for low intensity storms versus, you know, potentially eroding channels to waterways, as well as it provides environmental benefits from removing pollutants. It provides a habitat for wildlife, and also in many instances also can be a fun community project where you can engage your members or even, you know, property owners. It's something that can be an added value to a property that does have benefit for improving water quality. Stream bank stabilization. I see this a lot, and this is a challenging topic because there's a lot of material that gets removed from the erosion of these banks that gets brought to the waterways. So if you're planning a dredge project and you're looking at substantial cost to do that, you want to correct these type of situations, because it's just going to accelerate the sediment accumulation, material accumulation back into your water bodies. So I see around a lot of the impoundments that we work around that this is a fairly typical condition. It's not as easy to implement as the inlet filters or rain gardens, because typically this involves permitting with the DEP. However, to me, it's something that's critical that be addressed as part of the overall assessment, because again, if you're going to dredge and don't fix these problems, you're really not taking the best action you can to minimize or reduce the amount of material that's being brought to the water body. So it reduces the volume of sediment and nutrients from entering the water bodies. Also improves the flow characteristics of the channel, which is important because then that also helps to reduce the future degradation of the channel, and prevents the loss of land, vegetation, and damage to adjacent facilities, which, we have circumstances like where these type of channel erosions are encroaching on roads, utilities, structures, and at that point it's becomes critical and more of an emergency type of condition. So, here's something that is an eroded bank, here's a restored bank. Permitting requirements. I'll just run through some of the permits that we typically see. So we generally look to a general permit 13 for lake dredging. That allows us to get the approvals that we need from DEP. There's certain characteristics. We're allowed to do up to 1 acre of wetland disturbance within the water body. Transition area disturbance that are allowed for access and things like that, subject to discussing and reviewing with the DEP, but this would be the primary permitting mechanism that we would look to do for lake dredging. Then there are flood hazard individual permit requirements that we look to for each circumstance. Depending if you're working within 200 feet of your dam, you may have to get a permit from dam safety. Many times I'll just proactively engage the folks at dam safety just to let them know what I'm doing, the approach to the project, and that usually is very beneficial. Fish and wildlife, if you're going to do mechanical dredging and lower your water body, you're going to need to get a fish and lowering permit, which you probably all are familiar with that process. I think it's the cheapest permit that I can see out there. County Soil Conservation District approval is going to be required, and then potentially a construction activity stormwater permit 5G3, which is stormwater that's being potentially impacted by sediment and being discharged to surface waters, is a consideration. So basically, I'll leave you with these final thoughts.
I'm sorry, John.
Yes.
Those are only New Jersey permits.
Correct.
So I was involved in a committee in my community looking at dredging, and we flowed into Lake Apacon and the Delaware River. We were told by an engineering firm that we had to go all the way up to EPA. Now this is 20, 25 years ago. I don't know if things have changed, or would we have to consider all the downstream bodies of water that our water goes into?
Not as part of your permitting. So your permitting would make sure that the measures that get approved can address those water quality, sediment concerns, things of that nature. So with respect to where the water goes off-site, there's always a concern with respect to how those discharges could potentially impact those downstream tributaries, water bodies.
Because you were told that's connect on Delaware River and then all the way up to EPA.
No, there's not a permitting requirement. Again, maybe what I would do in those circumstances, I would, engage the folks, Musconetcong and others, and let them know how you're planning to approach it. I had I'm representing a county on a dam project, and we had public information hearings and things like that. We were actually looking at doing a dam decommissioning, and there was a significant amount of sediment accumulation in the impoundment. So as part of those public information hearings, there were downstream concerns raised by other impoundments downstream about the mobilization of sediment from that impoundment downstream. So ultimately that changed the direction of how that project proceeded, but the permits were just the permits for that project. It did not involve getting permits or approvals from anybody else downstream.
Thank you.
So closing remarks, from my perspective, the health of lakes are really critically important to lake associations, right? Again, as I mentioned earlier, there's a lot of value from recreational, fishing, navigation standpoints. So it's a very critical objective for associations. I thought hard about using climate change because I just don't want to get political or whatever, but the reality of it is climate change, at least from the way I view it, has had an impact, is having a substantial impact on water bodies and impoundments. New Jersey DEP has published studies that now are being implemented. For you folks that are dealing with dams, last July they started implementing higher rainfall intensities and values that you have to use now for your hydraulic studies, based on scientific evidence that says runoff in New Jersey is now greater than it was 20 years ago. So that's a topic for another day, but go back to the slide I had about stream degradation, right? So those increased intensities of storms, higher flows, the short duration, high intensity runoffs are really having serious effects on our water bodies. And it's something that we can't discount and have to give significant consideration for. So for me, that's something that's affecting our regions and changing things that we never had to look at and were faced with before. Watershed development continues to accelerate. I'm not necessarily against development, but I work many times for property owners that have water bodies that are having to deal with planned developments upstream from them, which significantly increase the runoff. And the one thing that folks don't realize is a great concern is that for these developments, when they get developed, they're being looked at for the regulatory standard. The regulatory standard is the 100-year storm, right? So they're designing their stormwater management features and things like that for that storm. I have clients that have dams that are regulated for a half probable maximum precipitation or a full PMP, 18 inches of rain in 24 hours or 36 inches. So if I have a 100-year storm at 8 inches of rain versus a half PMP storm at 18 inches of rain, where's that extra 10 inches of water going? It's going to my client's lake and then dam that has to manage that water. Who's paying for that? So it's a significant gap in the technical process of evaluating stormwater. Near-term and long-term watershed management strategies are really critical. This is not, watershed planning goes on forever. I mean, this should be a highest priority for any owner of an impoundment, and you have to be passionate about it, because there's always going to be pressures put on the lakes, impoundments, tributaries based on what's happening in the watershed. And as you know, the lake for associations is probably your greatest asset, right? I mean, it increases the value of your properties. A lot of your members move there because it's a huge attraction. You know, people love going to the beach, the recreational values. It's just your greatest asset. So watershed management, I can't emphasize it enough. And it's something that you have to just work at all the time. So that's my 10,000-foot view. Be happy to take some questions. I've got a hand all the way in the back first.
The sediment study, do you have cost per acre for that? Ballpark?
I mean, it can, depending on what you want to look at initially. If you just want to look at the physical composition of it, you know, you're probably somewhere in the $7,000 to $10,000 range.
That would give you an idea.
Oh, not per acre. I'm sorry. Just to get that would just get you a general idea of taking some random samples throughout an impoundment. It's really, you know, I would look at, like I was showing in that one graphic, where there are areas that may be apparent that have more impacts than others. So before you get to the sampling and evaluation, we would look at those areas to identify potentially priority areas. Yes, sir.
You were talking about normal rainfall and having the dam hold that amount of water, and then for the 100-year storm, what did you call that part of precipitation that came down, that really strong flow?
There's the half PMP, which, so depending on the classification of your dam safety is going to say that your dam has to be able to pass the spillway design flood. So the spillway design flood will vary depending upon the classification of your dam. So a high hazard dam would potentially be a PMP, probable maximum precipitation event, which would be, you know, approximately 36 inches of rain in 24 hours. But that is different for each dam depending upon your classification. Yes, sir.
Is there any funding available from the state for dredging or hydraulic rigging if your lake is not had an algae problem?
Yes, so under the same loan program that most folks are familiar with that are used for dams, that also can be used for dredging. But there's a challenge with that. So if you're familiar with the application, there's a ranking system with points. So a dredging project would not get as many, doesn't have the opportunity to achieve as many points as a dam restoration project would. So I've had success with getting funds for dredging. It's unusual, right? Because if the funds are consumed for dams, then there's usually not money left over, and that ranking system would put a dredging project so far down on the list. But if it happens to be, sometimes there are periods where dam owners just don't happen to apply for funding under that cycle. You could get lucky and qualify. So under that same program, yes, funds are available.
Are these loans or grants?
Loans.
All business associations.
Yes, sir. Yes.
Is there a process short of full dredging for the removal of, you know, just light organic material that doesn't involve full-scale permitting that you outlined in your presentation?
I mean, you can cut organic, you know, weed growth and things like that, but DEP has now adopted a policy. I mean, many of you have probably heard hydro rigging, right? DEP has now adopted a policy that if you're essentially scraping the surface of the bottom of the lake, that's considered to be dredging, and that they will not allow that. So to me, that's essentially taken away any viable, reasonable way for a lake owner to remove any organic material. So short of removing vegetative growth by cutting it and harvesting it, I don't.
Has that been implemented yet?
Yes. Yes. Yes, sir.
Are there any highlands protection area permits needed for the watering locations?
Yes, so if you're in a highlands area, then there's an added layer of permitting that you would have to look at. Yes.
The survey that you showed earlier, does that include in front of the dam? You know, so you can see how much sediment is moving toward the dam?
Yes.
So you said it was 200 feet, you had to get a permit to be in that area, so we shouldn't go over that.
Yes, so in that, so in the dam is located here. So you know, our study encompassed the entire water body. Luckily, in this case, there's not as much sediment accumulation here, but potentially, depending upon the beach is here, so dewatering activities may occur here with some type of modification, so that may require involving dam safety. So it's not only potentially in-water activities, but also things that are occurring around the dam. So that would be a consideration. Yes.
Just using this as an example, your project here, what did it cost that association to do with dredging?
So it's just in the permitting process right now, so it hasn't happened yet. But the loan that was secured for this, which will not be enough to dredge, is $5 million.
Can you talk about the permitting process? How much that takes?
Permitting process would say, just round numbers, $500,000. Yes, sir.
How much is the study, and how often do you recommend it be done?
So the study, there's really not a set cost for the study. It depends on, you know, the size of the water body and things like that. So, I mean, a study could range anywhere from, say, $20,000 to $100,000, just to give you a range. How often to conduct one? Once you have a baseline study done, it's something then can be updated as time goes on, changes in the watershed, changes that you're observing in the impoundment. So time frame can be anywhere of revisiting it, say, every 3 to 5 years, depending upon, again, conditions.
And what is the range of cost to revisit?
Again, it would depend on impacts, but, you know, say the cost of that could be half of what is stated for the range of, you know, so it could be $10,000 to $50,000. Yes.
I want to revisit that permitting cost. So what are you including in that? Obviously the filing fees and the cost for the engineering firm to prepare everything. So regardless of the size of the lake, we're talking $500,000?
No, I mean, the size of lake would have an impact on the cost. However, many of the permitting aspects may be the same, but, you know, so you've got, I mean, starting from the basic overview level, you've got aerial topography, you've got mapping, you've got bathymetric surveys for water depths and sediment depths, you've got sediment characterization. Depending upon the composition, you may have more analytical costs. So certainly the costs for a small, Shawangum is approximately 70 acres in surface area. So if you have a lake that's a smaller surface area, you know, there would be a reduction in cost, but you're still, you know, well into a 6-figure cost for the permitting aspects of it.
That's, in some cases, years' worth of budgets for these
Sure.
associations.
Sure.
Might as well just fill them in.
I mean, the planning for this particular dredge phase started in 2016. And there had been planning prior to that, but the dam took a priority over that, so then dredging planning got delayed and then reactivated. Yes.
So, just the filing fees for the permits alone, do you happen to have a ballpark on what that is?
I don't.
Where was this lake located actually?
Randolph, Morris County.
As you've been doing these sediment impact studies around New Jersey, do you see any accumulation of copper in the sediment from treating for algae?
Yes, so if lakes have been using copper sulfate or other copper-based compounds, then it does increase the copper concentration in lakes.
How does that get mitigated?
It becomes an issue with respect to the disposal of that sediment, right? So the disposal facilities, if you're going to remove it off-site, the disposal facilities have their own individual permitting requirements. So depending on the facilities you're looking at, metals, various metals will have different levels than at various facilities. So you just have to look at that with respect to how you're managing the sediment.
Would that limit your ability to store it on site if you did have that?
Not necessarily, no.
Thank you.
You're welcome. Yes.
I had thought before today that biomaterial and sediment were treated separately. Now they're all dredging.
Yes.
And if I want to get down to the lake bed and not go past that, how do I determine what that is without historical data that tells me 40 years ago it was 8 feet deep here?
So when the coring is being done, you can see how black and organic that looks. In many of the soils in Morris County, the soils all have a different coloration and consistency. So it'll be a reddish tan, typically for the type of silts and clays that we have in Morris County. And then also it'll be cobbly, stony, gravelly. So usually from the core, it would have to be a physical core that would have to be done, but that would give the engineer an ability to assess.
So that would, a physical cores would be a requirement?
Yes. And then also, generally, the natural lake bottom is significantly harder than the sediment, so many times you're not going to take 1,000 samples, core samples, but you'll take a probe rod and you'll push, and the organic material is much softer than the natural lake bed. Yes?
In this group previously, we talked about the difficulties of finding organizations to take the material that you remove from your lake bottom. Do you have that experience, or are you readily finding people that take the material? There are numerous ways to dispose of the material. So that's not so much the challenge. It's the process between the lake to getting it there, and the permitting and analysis and all that is, once that's all figured out, then there's places to take it. It's just how much money you have, and that's the challenge. Yes.
So I'd like to question, how do you define lake bottom? And the reason I'm asking that is I know that our lake, White Meadow Lake, had appeared and disappeared several times in the mid and late 19th century, depending when they needed water for the White Meadow Lake mines and when they abandoned the White Meadow Lake mines and when they brought the White Meadow Lake mines back online. When they didn't need the water, it became a marsh. So, and then there's other lakes like in Morris County that were man-made lakes, for recreation communities. So their in our case, White Meadow Lake and these other lakes in Morris County, the lake bottom is really an old marsh, an old swamp. So how would you define a lake bottom when it's really an old marsh or swamp?
So for an old marsh or swamp, generally when we core it, we'll see evidence of that organic material. You'll see a peat layer, or you'll see the actual former wetlands composition, right? So that will tell us that in that particular case, that was where the natural grade had been. So that would define your lake bottom.
What form of dredging is planned at Shunga?
It's still in the final processes, but likely will be mechanical. With the water level maintained, and then drafting barges and grapple equipment for the removal. But a contractor still has not been selected, and that's also part of the permitting process. The DEP requires that we specify the method of dredging to obtain the permit. So we'll likely go in with mechanical in the event that a contractor comes along that is uniquely qualified to do hydraulic and wants to do hydraulic. We would have to go back to DEP and amend the permit.
And what's their dewatering plan and their disposal plan?
Dewatering plan still in progress, but a combination of using existing on-site facilities for managing some of it, and then the beach area is another dewatering area, which would then material would be removed before the next spring-summer season to make the facility usable again. And the dredging would potentially occur over a number of seasons. Yes, sir.
Who's responsible for holding the permits? Is it the contractor assigned to do the work, or is it the lake association that's hiring them?
Generally, the permits are in place by the time the contractor is selected. So there, with respect to, say, particular means and methods that a contractor may have, there may be some modifications, but generally these permits are obtained before. Okay.
Can you go back to the slide with the list of permits?
Okay, well, thank you for your time.